And I just wanted to add also, like if there's a clarifying question or if like an abbreviation or acronym that I use that doesn't make sense, please feel free to put that in the chat. And I've asked Chris to interrupt me. Like if there's questions that you have for understanding the material, I'd like to address those sooner rather than later. Larger questions, I might wait until blocks during the presentation to stop and address. But thanks everyone for joining today. I'm really excited to talk to you about this research and development project that I worked on with Efficiency Vermont. The research took place mostly last year in 2024, but the whole report finally just wrapped up just recently, which is, you can see from that link that Enrique posted, there's a lot of work in there. And this is just going to touch on pieces of it. But the whole premise behind this research really is as the energy code becomes more stringent with each update, and we just had one last year in 2024, the available energy savings, and this means like the difference between the program requirements and the code baseline, those savings from the Efficiency Vermont Multifamily New Construction Program are diminishing, which makes sense. So we really wanted to look at, does Passive House certification offer additional benefits over our current high performance program? Okay, good. Okay, so these are, just like the main objectives we're trying to answer here, but left over from Better Building by Design conference, so bear with me. So I wanted to mention that I do use some abbreviations and acronyms during my presentation and also in speech, and try to address those right off. EVT stands for Efficiency Vermont when you see it here or hear it. HP, high performance, and PH, of course, is standing for Passive House. MFNC stands for Multifamily New Construction. And I also tend to refer to Passive House Institute US as Phius. Everybody says it a little differently, Phius, PHIUS, but if you hear me say Phius, that's what I'm referring to, the Passive House Institute US. So here's the cover of the report, and another link if you get the slides. But I wanted to start by telling a bit of a story. About 8 years ago, the first certified multifamily passive house in Vermont had just been completed. I was the Phius Plus verifier on the project. And many of you know Chris West, who was the certified passive house consultant on the project. Anyway, I had just finished verifying the project for really great air tightness, an excellent efficient balanced ventilation system, domestic hot water recirculation system. It was well built, airtight, and as verified by the owner and the occupants, comfortable, quiet, and used little energy. Fast forward 8 years later, and it's the first and only certified multifamily passive house in Vermont. In this session, we're going to explore why that might be and what might be needed to increase the number of certified passive houses. Just a brief look at the agenda. I'm going to give a little bit of background on the study itself and then dive into the results. And those are broken down into energy consumption, cost, and partner feedback. And then we're going to talk a little bit about opportunities and barriers. And in this initial section, I'm also going to give a little bit of background on passive house and high performance for those who might not be super familiar with the differences. These were the research questions that we were trying to answer. Really, like I already stated, is the certification cost effective when we're comparing it with Efficiency Vermont's high performance multifamily program? And we wanted to look at all the aspects of the available incentives and of different types, like both tax credits and low-income housing tax credits. And we separated the information, the data that we were gathering into 3 categories: energy consumption savings, costs, which I'll talk more about, was very challenging to get and quantify for projects of different ages, and qualitative data from interviews with folks who had built certified passive houses in the study. And also, this is a good point to mention, like I mentioned that project was 8 years old. So some of the buildings that I'm using in this study are they completed from 2017 all the way up to 2023. So there's a variety of age buildings in here, which makes looking at the data a little interesting. There were 10 buildings total in the study, and because only one was in Vermont, 2 of the passive houses were in New Hampshire and 1 in Maine. And this study really is unique. There's a lot of studies out there comparing passive house certification, even in multifamily, to other certifications. But I think this one really stands out that it's looking at 2 very high performing standards and asking the question, is there still savings that can be found from the difference there? And if you're not familiar, there's 2 Passive House certification standards that still exist, Passive House US and Passive House Institute International. And mostly what we're going to be talking about here is the Phius, Passive House US, because that is the majority of the buildings that we're seeing certified in the area. And those are the 4 that were used in the study certified under Phius. And that program or that standard requires prerequisites of Energy Star, Indoor Air Plus, and Zero Energy Ready Home, the federal programs. It requires those as a prerequisite for certification. And we're looking at multifamily here. Multifamily just historically has been better incentivized and supported than single family homes in state incentives, not just in Vermont, but and the reason for that is really because it's generally more cost effective due to scale and surface to volume ratio of buildings. Like, you have to put a certain amount of money into the shell of the building, and that's going to get you a lot further with a larger, higher volume building per shell. And I also, for those who are familiar, who have a history with Efficiency Vermont and know our high performance labeled programs, there was a high performance tier for single family, which was really kind of a passive house light version for single family homes, which was really, really kind of close to what you'd expect for a passive house, like our 40 walls, our 30 slab insulation. This multifamily program is not that. It's pretty different. And while it's still well above code, it's not quite to those high levels of the single family. And I'll tell you more about that coming up. Here's a comparison chart, really looking at the differences between Efficiency Vermont High Performance and Passive House. One of the biggest differences is the prescriptive checklist versus performance standard. So high performance uses just a basic checklist, and you just need to meet the criteria of that to get the certification, whereas Passive House is really based on energy modeling that happens early in design, and the project has to meet these strict energy targets or limits and is verified by this modeling and by the Passive House certifying entity. So that allows, one thing I just wanted to highlight here is that EVT High Performance is a specific Vermont program. It does not exist anywhere outside of Vermont, and completely created by Efficiency Vermont. It's had great success, so that's a good thing. But it's not something that's easily translatable outside of the state. But that allows us to have more flexibility with it. We can customize requirements if needed and encourage certain actions, which when the code changes is really helpful for us. Whereas Passive House, those targets are fixed, and maybe they get developed a bit with each change of the program, but they don't change really that much. Those targets are fixed, and what you have flexibility with is the use of the tools within that to achieve your target. So you can adjust your R values of your envelope insulation. You can adjust the efficiencies of your mechanical systems, but all together, obviously that has to meet this final energy target or limit. And those are heating, cooling, and source energy. And one of the biggest differences is all going to be tied into cost, which is the Efficiency Vermont staff are actually pretty heavily involved in the projects that go through the high performance program. And we have experienced technical staff who provide assistance at really no cost to the enrollee or the customer. which helps, like when you're comparing it with Passive House certification, the developer or the owner needs to hire third-party consultants for the energy modeling and the verification piece. And also there's a cost for certification itself, whereas there's no enrollment or participation fee for Efficiency Vermont High-Performance. When we're looking at the available incentives, there's very little difference there. Currently, this stuff is just kind of always in flux, but at the time that the study was done, really, you're not going to get anything extra for doing Passive House than you are for Efficiency Vermont High-Performance. And really the main difference is that Passive House can qualify for one QAP, the qualified, what does QAP stand for? Qualified plan for the low-income housing tax credits. You can get one check mark in addition for either meeting Passive House or zero energy. But we've learned through conversations that it's not really adding a lot of value and not enough to really move the needle. And I wanted also to highlight the verification requirements, which is one of the things that really sets Passive House certification apart. The requirements for the third-party verification throughout construction and at the end of the project really is very rigorous and results in a project that you can feel really confident about the performance of because it's had so many eyes on it and has so much testing. And Passive House also, I wanted to highlight that because of these sort of stringent requirements and this review that's done by the certifying entity, they really encourage, and not just encourage, but require reduced thermal bridging, assembly moisture risk mitigation through review of the assemblies, certain comfort metrics for the interior temperatures of the materials, and all of these things along with those other programs that are required, Energy Star Indoor Air Plus and Zero Energy Ready Home, they really, result in great benefits for occupant health, safety, and well-being and durability of the building. Here is a summary of the Efficiency Vermont High-Performance requirements. This is mostly just showing the envelope requirements here. And in addition to this, there are very energy efficient appliances and mechanicals that are required. And those are going to be pretty comparable from program to program. So I didn't highlight that as much. But you can see it's a pretty high performing standard. These we're asking for R12 continuous insulation outside of the sheathing on the wall, the flat roof, R60 for a flat attic roof. This does not require triple glazed windows, but the window requirement is still 0.27. And yeah, you can see it all here. The air leakage requirement recently changed. We updated this with the new code. And so now requires 0.075 CFM50 per square foot of shell, which if you're familiar with Passive House of 0.06 CFM50 per square foot, we're not that far off from that yet. And meeting these criteria can earn a project an incentive of $3,700 per unit, which is incredibly helpful with the high cost of construction these days. And yeah, this program is unique because Vermont really is of all the states that I looked at as part of this study, it's the only state that has its own program, its own checklist that was created in state. All of the others are overlapping with programs are really based on Energy Star mostly, or Zero Energy Ready Home, and then maybe layering some additional requirements on top of that. But it's pretty different, I'm learning. So when we selected the projects for the program, for the study, we, like I said, picked 10 projects altogether. 6 were high performance and 4 were Passive House. The criteria included, they had to meet all the criteria of either program and be a Passive House certified. They were all in ASHRAE Climate Zone 6A. They all had similar massing, so a double loaded corridor layout, with all of the units like in one main building, mid-size, 3 to 4 stories in height, and they ranged from 24 to 42 dwelling units, and also ranged in square footage from 21,000 square feet to 44,000. And most notably, all of them had really low air leakage. That was one of the pieces of the study that we wanted to sort of normalize across all of the studied buildings, because we know low air leakage can have a really big impact on reducing the energy use of buildings. So all of the buildings met Passive House air tightness requirements, except for one. There was one that was slightly higher. But in the end, actually, it doesn't really show up in the data. So that was kind of interesting. And all of them, we didn't actually attempt to do this, but all of the projects were affordable housing, were developed by affordable housing developers. So I'm going to talk a little bit about the energy consumption data that we gathered, and also wanted to give a shout out to Emma Cassavant at VEIC for helping with that. She was really instrumental in helping gather the data and analyze it. And we looked just at energy consumption. This was a pretty low budget research project, so we had to really limit what we looked at here. And the idea was that by normalizing all of the energy, by not looking specifically at cost and just looking at the energy itself, we could normalize that across all fuel sources. We used AMI, which stands for Advanced Metering Infrastructure data, the electric data that's available to us. And we gathered fuel bills from those projects that were using fossil fuels as well. And we converted all of that to KBTU and then calculated the site EUI for each project. We did not look at source EUI, that was out of the scope. And also out of the scope, we did not look at any decarbonization related goals like embodied carbon or carbon intensity of the grid or GHG emissions. Those are all great topics maybe for another future study. And I just wanted to mention with the conversion to KBTU, with an eye towards an all electric and net zero future, which really seems to be the direction that a lot of us are going in and a goal of the state. So reducing total energy consumption of a building as far as we can cost effectively will be really necessary to transition to a decarbonized future. So we were looking at it with that lens of just, steps to make the building use less energy. It's all good. Okay, so results. This is what you're all here for. This is a metadata table. It's broken up into 6 projects that I'm showing here, which are the high performance. And on the next slide, I'm going to be talking about the 4 projects that are Passive House. This is really just giving that basic data that I talked about the ranges of here. But one thing to note, I guess I'll give you my summary. These were 10 buildings, 6 high performance and 4 Passive House. The high performance are A through F, and the Passive House are G through K. The energy consumption is assessed on both an EUI, which is KBTU per square foot per year, and per bedroom basis, which we thought was a better reflection of the use per occupant. Buildings B and H are all electric, but the rest of them rely on either natural gas, propane, or oil for all or part of the heating and domestic hot water loads, mostly domestic hot water. Some of them are using...
Karen, sorry I interrupt you about the chart. The charts only, we can see only up to building F. So
yeah, I'm going to move to the next one in a second. I couldn't fit them all on one slide and have it legible at all.
I thought you could reduce
just give me a second. I just wanted also to mention that they all have energy or heat recovery ventilation, and only one of them, building K, doesn't have air conditioning. So you've had a chance to look at that. So I'll show the Passive House projects here. And notably, all of these are using some sort of heat pump for heating, except for building K, which is using electric resistance heating. And we also have an electric resistance heated building in the high performance group, which is building E. Building E is electric resistance. Most of them you can see are using heat pumps. A and F are using natural gas boilers for heating. So here's the table with the chart with the results. Sorry. It's broken up again into A through F are the high performance buildings on the left in the solid colors, and G through K are the passive house buildings on the right in the hatched. The green on the bottom is representing the electric consumption, and the blue on the top is representing fossil fuel consumption, which varies per project. So you can see the ones that are just green are the all electric buildings, B and H. This table is showing the, graph is showing the showing the EUI, the kBHU per square foot per year. And then I have the per bedroom shown on the next one. But you can see, before I go to the next slide, there's a wide variation in EUIs that was seen, specifically in the non-passive house buildings, which is interesting because, and then we're seeing like less variation among the passive house buildings, although, maybe not as low as we'd like to see. But this was a similar outcome that was observed in the evaluation with the Massachusetts Passive House Design Challenge that was done by the Mass CEC. If any of you are familiar with that, they noticed that there was much more variability from project to project in the non-passive house certified buildings, which really, if you think about it, what I was talking about before with the required energy modeling at the beginning of the project, the strict energy limits, and all of the rigorous verification, it makes sense that the projects would all be pretty much the same, assuming that they're performing the way that they were designed to perform. So going to the next slide, you can see when we look at it per bedroom, there's a bit more variation here. We're seeing some similar trends, but it's kind of interesting. I feel like you don't often see energy use displayed in a per bedroom metric. So it was just interesting for us to see like some of those lower EUI buildings are even lower when you look at it that way. I am going to go to the next slide here because this is kind of a summary of what we looked at there. So the average EUI for the high performance buildings is almost 38, and the average passive house is 30.5, which represents a 19% improvement. Looking at it this way, so per bedroom is similar. It ends up to being about a 20% difference. But the range is really interesting. For the EUI range, as I was just talking about, it's a much lower. This is not an EUI number. This is just like a points range between the highest EUI and the lowest EUI. So you can see that there's a considerable difference between the highest and the lowest of the high performance in the passive houses. And also, it's interesting, like, to look at with, with respect to these numbers. NREL created an EUI target for zero energy multifamily buildings not too long ago. I want to say like within the last 5 years. And it's 24. So, I mean, very few of these buildings are actually in real consumption, getting to that point. None of them in this study. So I just think that's interesting to note, like where, we're expected to go from here. We're getting close. And I have another thing I wanted to say about that. I moved this slide up at the Better Building by Design conference. I actually had it at the end, but I think that this is a lot of what people want to talk about and look at. Because we were trying to find patterns, in the data to make sense of it a little bit better. But I think I lost my train of thought, but let me just get back to it. So B, C, and E in those charts that we were just looking at really are the lowest consumption buildings, which is pretty interesting because they're high performance. And they're all family housing, which was surprising to me. I kind of expected senior housing to perform at a lower EUI than family, but they're kind of all different. One is completely all electric with heat pumps, heat pump heat and heat pump hot water heat. One is heat pumps with oil boiler backup and domestic hot water, and another one has electric resistance heat with propane backup and propane hot water heat. And I'm going to jump to the last line there. Building D, so you think like, okay, heat pumps are really helping to lower the EUI, and they definitely are doing that, but it's not any guarantee because building D was an outlier. It actually had one of the highest energy consumptions, and it has heat pump heating. And interestingly, like after we completed this study, a couple of us found some additional projects to look at, excuse me. And they didn't exactly meet the criteria of the study, but were close, and they were all electric buildings, and they were getting to that sort of net zero target for multifamily of 23 and 24 EUI. And they were all electric with heat pump heating and electric resistance, domestic hot water, which I thought was really interesting. And also very low area leakage. All right, I'm going to stop there actually for a second and see if there's any questions I can answer.
I don't see any pertinent questions here, Karen.
Okay.
Isaac from Phius mentioned that they are available for help and in the future. And Enrique mentioned that the Efficiency Vermont High-Performing Home Program is kind of weak on Windows. But I want to point out that in your research going forward, let's start comparing envelope. Because I'm thinking, what is the difference here? Are we looking at insulation envelope and R values possibly, maybe window performance? If all these buildings have relatively high levels of air tightness, there must be another variable that's not being addressed here.
Yeah, that's what we're talking about. And
Yeah.
I don't think we have any way to really know, since this is real world consumption data, without like a really detailed study dialing in to individual loads. It's hard to know what's really driving the different use. I mean, we can hypothesize, and that's kind of why we put this together. So at least we could look at the mechanical systems, because that tells you something, comparing building to building and understanding sort of what's driving some of those EUIs. But yeah, it's a great question. Like there are definitely some surprising things in here.
Yep.
And I would have loved to have had like a data set for this study that was about 5 times bigger, but alas, this is what we ended up with. So I'm looking forward to seeing studies that maybe come out of the NYSERDA Buildings of Excellence program, which I'll talk about in a minute, which has a much, much bigger number of buildings.
Kate is asking if the Passive House Challenge, Massachusetts Passive House Challenge building, are there any report published from them?
Yes, and I talk about that coming up. I'm going to talk about that in just a minute, because that comes into play with the costs section. So this slide, is it all right if I go on?
Yeah, go ahead, please.
Okay, so this slide is just highlighting how affordable housing, specifically development costs, really have skyrocketed over the past years since like the first building of this study was completed. And I would say this is even old now, and costs are basically double what they were back in 2018. So, I mean, it's just to highlight the challenges that affordable housing developers are dealing with right now with respect to costs. When we looked at costs, we broke it into 3 categories: soft, hard, and design. So the soft I'm categorizing as like the consultant's fees, the passive house energy modeler and verifier, and the certification fee. The hard costs are all those pieces that are going into the building, the materials, the equipment, the construction, and the labor to put them in. And design is a little harder to quantify, or a lot harder. It's like the additional time that it takes a project to design to Passive House with no experience to start with. And this was one that we weren't really able to quantify, so we kind of just are naming it. But in many studies, it has been found to really diminish and pretty much go away over time with experience of the project team. So we found that the total costs were about 1 to 4% higher than standard development. I also want to say that we originally set out to do like a cost comparison of project to project, but really quickly found out that was very challenging because these projects were completed at different times. And as I just showed, costs were increasing rapidly during that time. So due to inflation and material price volatility because of the pandemic and supply chain issues, it was just incredibly challenging. So we ended up really focusing more on the soft costs to really identify, and learned that even those went up quite a bit. So from that first, that only certified passive house in Vermont, the costs went from about $1,500 per unit to closer to $3,000 per unit for a project that was estimated about a year or so ago. So that's just interesting to see. It makes sense to me, that costs are increasing altogether, but not making it any easier to certify, really. And verification, like that on-site, the Phius verifier or rater, that there's a lot of time involved with that. They are pretty much on the project from the beginning to make sure that it's on track to meet all of those federal program requirements. And then they're doing regular site visits for multifamily. It turns out to be somewhat frequent because of the scheduling of the project. So that turned out to be like half of the soft costs of the total project. And as I mentioned, those costs have really doubled. And the incentives, while significant, they are, but they're not any different, as I mentioned, for passive house. There's nothing available for PH over HP. Here's where I talk about those other cost studies. And these, with the slides that I'm going to provide, these are live links. So you can, hopefully it's still accurate and works, but you can use that link to get to these studies and read more about them. This is just kind of a brief summary of each one. I think the two that are really highlighting some important takeaways, they all are, but I would say the two maybe that are the most valuable for the Efficiency Vermont and those of us who are working on trying to make passive house work programmatically are the NYSERDA, the two that are listed first, the NYSERDA Buildings of Excellence and Massachusetts CEC study. And those are showing pretty similar results to what I just mentioned. I'm not going to go through all of this because I'm definitely going to run out of time, but I encourage you to look more deeply at this in the future. And just as a note to this, wanted to mention that, even since some of these studies were done, the code keeps increasing, right? The code, at least in Vermont, we keep updating it roughly every 3 years, and that baseline is increasing. So any incremental costs that we're estimating over code, those are coming down because Passive House isn't increasing its standard along. I mean, we're just getting basically closer and closer to Passive House and code requirements, which is going to, change that estimated additional cost. So yeah, this slide was really just to show what is driving the hard costs for Passive House. We're seeing higher levels of insulation, specifically in walls, slab, definitely, maybe a little bit of roof. Definitely the triple glazed windows are adding cost. And higher levels of air sealing definitely adds cost, but we're not actually considering that for this study because they already got there. More efficient HVAC system. I'm noticing like ventilation systems definitely are having an impact, and the more efficient systems are more expensive. And I don't see them used as often in projects that are not going for a standard as high as Passive House. And then there might be some more distribution for that ventilation system, but ventilation is required by the Vermont Energy Code now. So again, much less of a difference in cost between baseline and Passive House. We were able to look at increased cost for triple glazed windows over double glazed, just kind of a general budget sort of price using RS means. And we came up with an average of like 28,000 to 70,000 for these mid-size buildings just for triple glazed windows. So just for reference, interesting to note. Here's a summary of the new construction incentives, which I've talked a little bit about. This is showing previously, before our program was updated in 2024, we were offering $2,700 per unit. And that really bumped up significantly last year because construction costs are increasing so rapidly. But there's also, in addition, up to $5,000 each that can be earned for energy modeling, building envelope commissioning, and mechanical commissioning. And that's for the whole project. And it's interesting that those are all requirements of the Passive House standards. So assuming that the people who you're hiring are meeting the criteria of Efficiency Vermont, you'd be able to earn those incentives as well. I highlighted, shaded the line for the 45L tax credit, because if you've been paying attention to what's being proposed for the bill, they're looking to eliminate that. And that is a huge piece of what I think is making this cost effective right now. So if that does go away, which looks possible, it's going to completely change this conversation. And I wasn't able to say that the last time I gave this presentation. So it's just hard to know what's going to happen. But $5,000 per unit for meeting zero energy ready home, it's really impressive and super helpful. And I talked a little about the qualified allocation plan, low income housing tax credit check mark. So I won't rehash that, but there it is. And thank you to Vermont Passive House for offering a $500 cost reimbursement towards accreditation training. So helpful. I'd love more people to take advantage of that. So here's kind of like a summary. I just did a sample 30-unit building, used 3% as an average cost increase. Granted, it could ideally be less than that. And that worked out for a $15 million project. That worked out to $400,000. So not a small amount. And 100,000 of that is just soft costs. So that's really where your cost increase is, because if we're assuming that the 45L tax credit is available, then the total incentive for that project would be $276,000, which is not a small amount and really makes a dent towards that increase. But again, that's available for both Passive House and High Performance. I'm not talking a lot about market rate here, obviously, but I've seen several case studies that really show it to be financially advantageous for Passive House certification for market rate as well. So I'd love to see more case studies presented about that, because I feel like it's definitely, there's a lot of opportunity there. So just talking about some of the qualitative feedback that we received, talking to the affordable housing partners that completed certified passive houses, they really talk about the benefits that are both seen and felt. They talked a lot about consistent indoor temperatures and quiet, comfortable space with low cost to operate, but they always came back to cost. First costs obviously are the primary obstacle for them. And they're in this position where they're really forced to chase the highest return opportunities. And we really haven't seen any significant incentives for Passive House since that first project was completed in 2017, 2018. So as a result, I think that's pretty much why we're not seeing more projects. The one QAP checkmark in the low-income housing tax credits has not been enough to move the needle. It's kind of works a little bit differently in Vermont than maybe neighboring states, and that checkmark was available for both Passive House and net zero, but not required in order to get the funding, and a lot of it is sort of just a conversation. So we're not seeing it really move the needle. The question to certify or not, I leave that for now. That is a deep conversation, but one really big takeaway from this process, from this research, was getting to talk to these affordable housing partners and learn some of the challenges that they have had to deal with, even with a certified passive house. So it turns out that even having a certified passive house with some amount of commissioning is not preventing issues. One of them, which is one of the more famous, has had, issues with missizing of heat pumps. Another one told me about issues that they were having with the ventilation system where it was using more energy due to controls maybe not being set up the way that they were intended to be. And, Passive House definitely allowed them to be able to identify these things and address them, but it doesn't prevent them from happening, which I don't know of any program that does yet. And yeah, just stressing like all of the issues that the affordable housing developers are dealing with right now. There's so many. Okay, I'm going to stop here for a second again and see if there's any questions. I think this next section will go pretty quickly. I'll keep going if I don't hear anything. So this next section really just highlights some of the additional benefits that we're seeing for Passive House. But first, just like a comparison of the opportunities and barriers, many of which I've talked about before. The energy modeling that's integral to the standard and the process really lends a lot of benefit, allows that optimization of the envelope and the mechanicals, and provides more predictable results and gives more flexibility. And these things like being sort of really finalized almost before construction begins really limits changes that can happen in the field, which can be helpful and definitely keep costs down. And adopting Passive House at a greater rate really would help the state with market transformation from both training for the project team and increasing the Passive House, like third-party Passive House consultant market, or the number of consultants that are available right now. It's pretty limited, and many of them are coming from neighboring states that are doing more of this work. And having this independent third-party review and like rigorous verification process really helps in this nationwide accepted standard, I think really helps with regulatory requirements. We talked about greater savings. So, post-occupancy monitoring, commissioning, not required, but that's definitely something that's going to bring benefit to projects, both high performance and Passive House. But the barriers, again, cost, lack of certified professionals, and greater incentives really are needed, especially for the first project. It's a bit of a bit of a barrier, a bit of a leap to just start with a first project when you don't have any experience with it. So I think that's one of the successes that the Mass CEC program really highlighted. Resilience is a big one. Really, through the robust envelope and ultra low air tightness of a Passive House building, we can realize a lot of benefits that I think we are not currently realizing yet. I'm not going to talk a lot about this. Passive House US also has a standard that they're developing or have developed for this right now, which you could look into more. But really, I think there's a lot of opportunity with this aspect for using the buildings themselves for meeting for load flexibility and demand response. Energy modeling was something that came to the top as a real benefit of the standard. I've mentioned this already. It allows for that optimization of the design trade-offs, allows for the flexibility of a performance standard. And it gives you a model. I think this is another field where we're just going to continue to see improvements over time, because the models that were used back in the day when that first Passive House was built maybe weren't as accurate as they could have been. And it provided some issues. I mean, it resulted in some issues of offering a higher savings than was able to be realized. But as the tools become more advanced and more specific and accurate, we're going to be able to use these energy models for a lot more, I feel like. And they already are starting to be. But one of the sort of obstacles is that there's proprietary software required for all Passive House, both types of certification. So, it hasn't held up a lot of projects in a lot of places, but it's just something to note. And I'm learning that it's not really a huge barrier for using the model for savings calculations, because doing a baseline model with that same software is not a huge lift, is what Passive House consultants are telling me. If anyone has anything else to add about that, I'm happy to chat about that in just a minute. So this model actually, this predicted EUI that the model is giving you brings both benefits and some issues that come along with it if it's not something that you really can rely on. And I've already kind of mentioned the historical shortcomings of the software, but it allows you to have a view into approximately what is the energy use that we're expecting out of this building, and even looking at the uses of different components of it. And so you can highlight when there is an issue, with a high performance building, and you maybe don't have specific monitoring. It's harder to tell that. It's harder to dial in quickly to find out what the issue is when you come up with a situation with higher energy use. And one really nice thing about Passive Houses is that you really can rule out thermal envelope shortcomings, because somebody had lots of eyes on that and lots of testing, and you can be assured that unless a crane was taken to it after the fact, you're in good shape. All right, so conclusion. I just have a couple more slides left, and then we can take questions. So yeah, in conclusion, more incentives are needed for Passive House over high performance if we really wanted to drive that. Yeah, there's a higher predictable energy savings with many benefits, as I highlighted, and higher incentives are needed, and more support for first-time projects and Passive House training, Passive House consultants training. All those things would really help drive this market. But the good thing is that there are neighboring states that are doing a lot of great work, and there are a lot of good examples for us to look at and talk to and understand how they're able to work with the savings claim aspect and the getting the construction built affordably. I'm not even going to talk about this. This was something that pretty much, if Passive House wasn't included, these are the elements that we'd like to see included in the high performance program. But honestly, they're just getting us closer to Passive House. This is something that if you want to look at further, I really encourage you to look into the report. I took some time to research some of the neighboring northeastern states and what incentives they had currently available. So this was based on sort of maybe late last year, I think, or early this year. And the ones that are highlighted here that offer pretty substantial incentives for Passive House certification for multifamily include Connecticut, Massachusetts, New York, and Rhode Island mainly. And then there's a separate section with states that are really just incentivizing through low-income housing tax credits. And I think Vermont could be in this category as well. And some of them are using like a total development cost allowance, greater allowance for Passive House certification, which is also another tool that can be helpful. And that is it. Glad I made it through that. So I'm happy to answer questions and have a deeper conversation. And I see Isaac has joined and he can answer questions too. Thanks for coming, Isaac.
Feel free to unmute yourself and ask the questions there.
Oh, I wasn't sure. Happy to answer any questions if needed. But it was more, I was going to I wanted to add just a couple of things to what Karen just said, more as a based on some of our experience in the neighboring states. One of the things I wanted to emphasize, and we're seeing this in Massachusetts particularly, we're now, because of various policies, we're now certifying roughly 20 to 25 projects a year in Massachusetts. And what we are seeing, a key item that we've seen is that the time between kind of conceptual and completion has dropped significantly over the last 2 to 3 years, by about a year to maybe a year to 18 months. And I think that that's a big driver to the cost issue that Karen was referring to. There are now a number of construction companies that have got much more experience and are now able to really build to know what's coming and know what they need to do and how to schedule it and how to train their subs. In addition, the architects as well have gotten a better sense of what is involved, so that if you will, almost the iterative process that comes in has been lessened. I think that's an important aspect to it. That was just the major item I wanted to emphasize.
Is that something related to what Michael posted there about the process that I mean, it takes too long. What I understand, Michael, is that you say that the process takes too long, and when you have the incentives or the financing, it doesn't match with the whole process. You can unmute yourself there.
Yeah, I just meant that costs, of course, are important. So you want to do a lot of iterative work on comparing what systems you're using and how much they cost, and bring the whole thing in a balance. And we've already got huge teams doing these things. To add a whole other level of doing that, it just isn't time. Like, once we get the word that they got their funding, we're just running full speed to get the construction drawings out to bid in 3 or 4 months. And so it would be really hard to, while you're at the same time cutting costs, as you always are, to keep the passive house iterative process going.
Yeah, and that's what I was referring to as architects and engineers and the builders gain much more experience, and a lot of these architects and the like have now done multiple projects. That process that you're talking about, which was a major issue for beginning when they were doing their first and second project, really diminishes as they end up doing their fourth, fifth, and sixth project. So
except for, I think, in terms of the envelope, that is true. I think we've got that down, but it's all of the ventilation and the heating and the other systems, trying to get them to work. And it has a big design impacts. For instance, if you're going to do a whole building ERU, or if you're going to do it by floor, and that's what we haven't solved yet. The engineers, I think, haven't caught up with the experience that the architects have with the envelopes.
That's a good point, Michael. I think a lot of that is unfortunately getting worked out just within energy code update requirements, with the addition of required balanced ventilation. And a lot of projects, due to that really excellent tax credit that was available for 45L for Zero Energy Ready Home certification, and includes Energy Star. A lot of the issues that passive houses, who are just trying for the first time, have had are really related to those things, related to Energy and Star, and related to Zero Energy Radio Home. And with more familiarity with those programs, I just think we're going to start seeing, hopefully that knowledge gets passed from project team to project team, and we're going to see these things start to speed up with greater understanding through the industry, I hope.
My main takeout of this study is basically that a prescriptive process is all over the place. It's like a box of chocolates. You never know what you're going to get. While a performance-based process really, I mean, gets you to closer or to the target that you're looking for. And I think
exactly. Yeah, I think I always keep wanting to go back to stressing that this project only selected the most, pretty much like some of the highest performing Efficiency Vermont high-performance projects to compare it with Passive House, so that we could see, you know, are there savings that can be gotten there? But I think a more appropriate study actually would have been to randomly select projects that achieved the high performance standard. That would have been a better view, and we would have seen quite a different, more extreme, you know, difference between those two programs and those two standards. So really the question is, do we keep ratcheting up our prescriptive program and adding higher requirements to the checklist, or do we just skip all that and make the jump to Passive House certification as the new REACH, you know, program, with all of the benefits like I was trying to highlight in there?
We would like to see Efficiency Vermont at least offer Passive House as a alternative path to meeting the high performance program, and get it out there so that designers and around the state can see more that it's available. And certainly what Enrique is pointing out, the 4 Passive House projects are consistently performing evenly the same, whereas the high performing homes jump all over the place. And in trying to bring our buildings down to the lowest energy use possible to help aid our renewable energy goals in Vermont, we want consistency. And I think the performance-based energy modeling approach gets us that.
there is a question here from Keith. What is the assumed incentives reality for Efficiency Vermont relative to the next 3.5 years under the current federal administration?
Yeah, that's a great question, Keith. I mean, we're not anticipating any major changes, as a lot of our funding is separate from, you know, the federal influences. But I think, you know, assuming no huge changes in economy, like we can assume that 3,700 per unit incentive for the Efficiency Vermont high performance tier is going to be in place, at least, hopefully. You know, but things are always changing based on available budget within the organization. But, you know, usually we try to maintain the program through the code cycle. So, you know, ideally for the next 3 years, but that also is sort of up in the air a little bit too, as to when the code will be updated next. So yeah, that was a lot to say. We don't know.
Okay, if we don't have any further questions, I want to thank Karen for the time and the great effort that she took doing this report and this study, which is, I think it brings a lot of light to the situation that we have here in Vermont. And maybe it can serve the legislature to do something there to really put some incentives to the program there. It's here's another comment for me. Karen's point about the selection of the best of EVT's high performance building for this study is crucial. A random sample of EVT high performance building would have been even more widely separated from Passive House. Yeah, that's what basically she mentioned there. Okay, thank you very much, everybody. and for coming up. And we'll be posting this recording and also the slides at our website. Have a good day then.